Morning, guys. So right at 11 o'clock on the dot, so we got a jam-packed demo theater. We got maybe about 25 minutes because we'll have to give a little time for the next crew. This session is about virtualization platforms, virtual infrastructure. It's not about VR, virtual reality, or AR, augmented reality, right? So if you're looking for that, though, because it is this is a play on a song from the early 80s. Maybe I'm too old. I know, let's get physical, let's get virtual. Olivia Newton-John, okay, anyway. So try to get a little funny with the name, but the problem is virtual can mean many things, right? So I want to qualify it here. We're talking about virtualization. There's a virtual reality session later today at 5:30 in the Mojave Learning Center. So if you guys are interested in VR or AR or mixed reality or working with 3D on mobile devices or in gaming engines, come to that session, actually. This one we're going to talk about virtualization, though. So first off, my name is Rex Hansen. I'm product manager for ArcGIS Runtime. And so one of the common questions that comes up when working with ArcGIS Runtime, building out native applications, is can I deploy my applications or use my applications on a virtualization platform or an infrastructure? It's not just for mobile devices, right? This is also, obviously, Runtime can be used to build desktop-targeted applications. And so whether you're targeting Windows or Linux or Mac, the question about support on virtualized platforms or architectures is important and is quite common. So just a brief definition here, just so that we're on the same page. What is virtualization? I'll read it off. Creation or use of a simulated computer environment or a virtual machine that acts like a physical computer with an operating system, right? So there's basically a guest machine or machines that are operating on an actual physical or host machine. We get a sort of a brief architecture here that shows a traditional architecture, your PC sitting on your desk with hardware and an operating system and an application that runs on top of that operating system, versus a virtual infrastructure, a virtual architecture, where you actually have hardware, a virtualization layer, like a hypervisor, and a set of operating systems and applications that run within them, right? It's all been virtualized, but it's still working on hardware, just at a different level, right? So you do, the virtualization layer enables your virtual machines and your applications to access different levels or different types of hardware. That could include CPUs, cores, GPUs, graphics card capabilities, right? So some of the benefits, depending upon your perspective, are many. Actually, the first one is actually reducing cost. So whether it's cost to maintain on-premise hardware systems, so being able to leverage the cloud and minimize your on-premise hardware, or two, being able to minimize the amount of physical hardware that you need to purchase, actually, for your enterprise. So a couple of different takes there on cost, or the benefit of reducing cost with virtualization. Obviously, it's relatively easily managed and maintained. You've got one place within which you can actually manage and maintain virtual machines, virtual applications, right? So you can control and you can audit what's being used and when. Also provides a nice flexible testing environment, right? You need to spin up maybe customers that you're building applications for, or users within your enterprise might have different operating systems. You might need to be able to target those operating systems in a nice testing environment that you can spin up easily and quickly. Obviously, it's nice to be able to enforce security protocols. And so if you want to make sure that you manage and maintain different licensing or different communication protocols within your enterprise, you want to be able to monitor that easily to know what's available and when. Being able to monitor that within a virtual architecture is critical, and it's something that's easily done. Also, there's two other issues. That's backup and scale. Oftentimes, it's easier to back up these systems. You can store and then manage and maintain these systems a lot easier. You can scale out in case you need some sort of a surge workflow, where maybe in disaster recovery you need to be able to spin up a number of machines to be able to handle a specific situation. Virtualization architectures are designed to handle that. So just to give us kind of a lay of the land, virtualization, what and why, let's get beyond that and talk a little bit about the specific details. Now, there's a lot of players in this field, but there's some critical high-level players that we work with right now at Esri that provide a variety of different virtualization technologies that we can leverage. On the enterprise, obviously Citrix and a variety of their products, whether it's Zen servers, Zen desktop, Zen app, for being able to virtualize operating systems and applications. VMware and their hypervisor ESXi and Horizon View as their client, being able to work with vSphere and leverage on-premise virtualization architectures there. A very popular one is Microsoft Hyper-V, sometimes a little bit behind the curve, but very popular and pervasive. In the cloud, what we're seeing now is a lot of competition among the major players that are offering cloud-based offerings, whether it's virtual machines or it's hardware-backed virtual machines, such as Amazon, Microsoft through Azure, IBM SoftLayer, even Google is getting into the mix, Google's cloud platform. And those are some great providers and vendors that provide a variety of different options for virtualization infrastructure. Now, in addition to that, it's not just being able to virtualize a machine and being able to access hardware and many different, hardware in many different capacities. It's being able to get that information back to the client. And so there's a variety of clients that are available to be able to best leverage a virtual machine or a virtual application. And so I listed a couple of them here. Teradici. Teradici is a proprietary owner of a PC over IP technology that enables the very fast compression and decompression of imagery and bitmaps that can actually stream back to the client very quickly, so it achieves a very high frame rate. And so Teradici provides a client that works on a variety of these platforms. TeamViewer is initially a free option, now there's a paid option that they have their own proprietary mechanism for working with different remote clients, could be physical or virtual. Remote desktop is obviously a common option, somewhat limited, provided by Microsoft, but it's another client option. Some of these clients are built on different protocols. Some of those protocols are more conducive towards a faster frame rate or better experience. Citrix provides HDX, which works over TCP, VMware, PC over IP. VMware obviously working with Teradici and that protocol, which we're going to showcase here in the demo. And then Microsoft's remote desktop protocol, RemoteFX, which actually is a Microsoft protocol that enables a very efficient use of virtual machines or physical machines over a remote desktop connection if you have appropriate hardware to be able to support it. So let's take this a little bit further. Actually, you can see on the right side here, there's a little screenshot of the GPU-backed NV series VMs that are in Azure. This is an offering that they came out with last year. This is just a brief snapshot. Actually, the first one that's listed there, the NV standard option, is what we're actually going to showcase in this demo. You can see it's got 6 cores, 56 gigabytes of RAM. It's running on an SSD, and it's got one NVIDIA Grid Tesla M60 graphics card that it can leverage. Right, so quite a lot of power there. Okay, so how does Runtime take advantage of this? Well, so ArcGIS Runtime is built on a C++ core, and that C++ core allows us to leverage native resources available to a device, available to a machine on which the runtime is actually executing. So we're able to leverage both CPU and GPU intensive operations depending upon what's best for performance. So in this case, if you're working with dynamic graphics, labels, do I keep cutting out? Am I cutting out? Sorry. I'll hold it. So to leverage GPU-intensive operations, we've built the runtime so that it will be able to take advantage of your GPU, onboard GPUs. When you work with dynamic graphics, labels, animation, or you work with textures, and textures can be utilized within scenes, so scene layers, 3D objects within scenes, tiled layers, dynamic map layers, etc. Right? So a variety of different capacities there that ArcGIS Runtime leverages hardware acceleration, GPUs if available to the device. Rendering in Runtime is actually built on 2 different pipelines, DirectX, in this case DirectX 11 for the latest release of Runtime, and OpenGL, and a variety of different flavors of OpenGL depending on working with 2D or 3D. So the priority here with Runtime is use the graphics card. If you have the graphics card, use it. We have built into, so part of the platforms that we build on and part of the work that we're doing right now within Runtime is being able to fall back to software. So if a graphics card's not available or the graphics card that you have doesn't support the rendering pipeline that we support, the ability to fall back is critical. So that's some work that we're actually doing right now within the 100.x cycle of the runtime. We had this in some places in 10.2x as well, but being able to fall back to software, while it reduces the experience in the sense that performance is not as responsive, at least it will render and you can still interact with it. right? Ideally, though, what we want you to be able to do, what we want you to be able to do with Runtime is leverage your graphics card, right? Use these capabilities, make sure they're available, right, to your system, whether physical or virtual. That said, CPU is still important, right? So we're still going to be leveraging the CPU for a variety of things, right? The container, the application container, other components within the map or the scene, such as static graphics, different analytics or data processing that might happen as well. So there's a lot of other work that needs to happen there and needs to leverage the CPU, so it's really a balance at this point. Obviously, we're multi-threaded, so we can work on multiple CPUs, multiple cores at the same time, so we want to be able to leverage that too. The take-home there is that Runtime will take advantage of a graphics card, GPUs, and hardware acceleration through hardware if available. Now, here's just a sort of a schematic of how of a basic virtualization infrastructures that we see here. On the left-hand side, you might find something on-premise, like in an enterprise, where you have a virtualization server. We're going to build this on top of, most of them are leveraging an NVIDIA grid driver to be able to parse and access different NVIDIA-style grid cards that can be then splayed across multiple virtual machines or applications. VMware, Microsoft, and Citrix obviously support this in a variety of capacities. On the back end, we may have one or many NVIDIA grid cards. In this case, we'll highlight M60 because that's what Azure's using, and that's what we actually use in our data appliance. That's on-premise. The same experience is available in Azure and Amazon, and they all need to use some sort of remote display protocol, right, to be able to get back to a client. This involves some software on the server. It involves software on the client, right? And we talked about this before. I briefly mentioned it with respect to Teradici or TeamViewer or remote desktop. And so our client endpoint needs to be able to access and work with these virtual machines, virtual applications that are spun up in these different locations. And what that means is that Runtime, because it can take advantage of hardware capabilities, is that we want to be able to leverage Runtime and Runtime apps. This doesn't mean just one app per virtual machine. This means you, just like any other physical machine, you can install many Runtime apps on one machine. That you can leverage those apps, install and use those apps, whether you're working on enterprise or on-premise or you're working in the cloud, right? So the Runtime apps will function, but we actually encourage you to take advantage of the capabilities that the platform provides, right? So if they're able to provide GPU-backed VMs, let's use those. If I'll kind of highlight the fact that Teradici has done a great job of building out a client and a client protocol that enables you to work quite effectively with some of the power on the back end and be able to reflect that in use of the client. Any questions thus far on this? Right. Right. So generally, so the question is, how do we know whether or not our rendering pipeline will actually support the graphics card actually that you're using? So the key there is looking at the hardware capabilities to make sure of the graphics card to make sure that it supports our rendering version and pipeline. Right. So you need to make sure your graphics card supports DirectX 11, actually, or in this case, I think it's OpenGL ES 2.1 if you're 2D. I think it's OpenGL ES 3 if it's 3D right now, actually. So. Okay, I'm going to pin this, and we're going to look at a quick demo here. Unfortunately, I wore a loose shirt today, so things are a little floppy. There we go. Okay, here we go. So what I've done here first is I have a couple applications. I've got two virtual machines. One is not a GPU-backed virtual machine running in the Azure cloud. It's got one core. It's got 3.5 gigabytes of memory. It's the smallest VM you can purchase today. It's about $96 a month. Actually, at this point, let's just see what we can, we're penny pinching here. We're trying to figure out exactly if we can run a Runtime app on this thing and make it work. We actually don't have a graphics card dedicated to this, so it's going to be using software rendering. So, but I'm going to use remote desktop. We're trying to keep this thing low cost and see if I can make this thing work. Okay, great. So what I'm going to do here is I'm going to open up two apps. One is going to be ArcGIS Earth, which is built on a 10.2x flavor of Runtime. And then the other one is going to be a new app that actually shows our client-side graphics rendering using dynamic graphics. It's not available in the Runtime today. It will be in update 1 in the end of May. At this point, we'll show a lot of moving graphics to see what happens there. Now, in this case, I'm building a WPF app. Obviously, Earth is a WPF app. I'm going to show a custom WPF app with Runtime. I'm using the WPF performance tools that are available for free on Microsoft just to illustrate what's being used, the frame rate, whether we're using hardware rendering threads, if there's any video memory usage, and also being able to show whether or not there's a graphics card. So there's a couple different tools I'm using here. There's a lot of tools out there, so pick the one that works best for you and gives you the information you need. I'm also going to use something called GPU Shark, which is a free utility. All this does is just give me like a nice readout of actually what's available on the machine. And so we can see here, there's no graphics card, right? We're going to be using software rendering here, and we're going to be leveraging what the platform provides for software rendering. So we're going to be hitting the CPU. I'm also going to start up Task Manager here so we can see some of the other stuff that's working on here too. Now the first thing I want to do is I want to start up ArcGIS Earth. So we'll launch this thing from the Performance Tools experience here. So it's going to take a little time. Now keep in mind there's no GPU. All right, so we can see there's going to be a little bit of lag between my screen and that screen, but you can get the experience here. You can see that, all right, frame rate's probably somewhere around 15, 29, 30. We'll know that we're using remote desktop, and so immediately it throttles down to about 30 frames per second. Right, that's just something we can't control, basically. What we can see here is there's a little tick box here that shows whether or not we're software rendering or hardware rendering. I'm going to tick that. If it turns pink, yeah, that's all software rendering going on there, right? So I'm going to hit a layer here. Let's go to, this is a local scene layer package. What you can see here is we're hitting the CPU pretty hard, right? Almost 100% there. Obviously, the graphics card's not getting hit at all because it doesn't exist. As I start to maneuver around, I'm just going to close this because that's for the other app. If I zoom in here, you can see it's a little bit slow, kind of painfully slow. I'm trying to navigate my scene here. This is actually local data, so I'm not going across the wire here to get the data. All right, so I'm moving around. We can see the frame rate kind of bouncing around between probably, 10 and 20. Great. We're not hitting, there's no video memory being used. There's obviously no graphics cards. We're not using that. Great. So we can see some challenges there. I'm going to launch a different process. This is going to be our graphics. This is a custom app we built recently just to show off some of the new client-side labeling. This is using dynamic. Let me have this thing resize. Okay, we're going to pin this thing over here. Great, so we can see we've got some dynamic graphics layer, which is our graphics overlay, which is being rendered in a dynamic mode. Right, so it's leveraging the GPU as best it can. Labeling, it's using the GPU. At this point, I'm going to play this, and it's going to start moving those graphics. And we can see the the frame rate kind of bounce around a little bit here. It's a bit low. Not too bad, right? We're software rendering. I can see that, right? The CPU is getting pegged. Right, not too bad. So I start to move around. Well, let's say I want to track an object here. Let's move in, start moving this thing around. Oh, yikes, that's not good. Looks like we need to do a little work there. All right, good stuff. So that's an example of, I'm going to cheap out. I'm going to go with like the lowest VM I can possibly get. I got no graphics backend on this thing. Technically, it'll probably work, but your experience is going to be less than ideal, right? And I'm using a remote desktop. Let's go and disconnect. Now, in this case, I'm going to connect to an NV6 series Azure VM. It's GPU backed, using it like I mentioned before, it's an NVIDIA grid-based Tesla M60 graphics card. I'm going to use a Teradicci client. Now these are free downloads. Obviously this is something that needs to be licensed, but you get a 60-day free license if you want to try it out. I'm going to connect to my client. Now I actually do need a Teradicci software access service actually running on the client. And then I'll need this Teradicci client to be able to connect to it, actually. And this will enable the ability to efficiently transfer packets of data across the pipe, compress and decompress that information so it's effective. Let's go full screen, actually, on this. It's going to reset. Okay, great. So let's take a look at, I'm going to open up the performance monitor. Okay, great, and let's go ahead and open up, I want to start totally fresh, just so you can see there's no smoke and mirrors going on here. And we're going to start up GPU Shark. You can see immediately it recognizes that we have a, that's pretty small, isn't it? Fortunately, I don't have the zoom it on here. In the green there, which you might be able to see from the back if you've got like 2010 vision, it's hitting the GPU. You can see the different characteristics of the GPU. I'm going to expand this out a little bit so we can see what's happening. And then I'm also going to hit the, I'll hit Task Manager so we can see what's happening on the CPU too. Oops. And what's critical here too with these clients is being able to have the bandwidth to be able to support this this frame rate, the frame rate that you're looking to support, right? So you can have all the clients installed, all the graphics cards installed on the back end, and being able to leverage those. But if you don't have the pipe to be able to handle the throughput, you're not going to get the experience that you want. So make sure you've got a good pipe in place to be able to handle that transmission of data. I'm going to launch a process here. Let's go ahead and let's launch Earth. Let's see how it performs. This is just a visual analysis of comparison and contrast of how these work. Now we can see here immediately the graphics card's getting hit. You can see how responsive that is. Let's go ahead and we'll take a look at, okay, CPU's not getting hit here. We see GPU is about 11. We can see video memory is getting hit, which is great. Frame rate's around 50. Let's go ahead and zoom into, actually let's take a look. I can interact with this globe and still basically have a very similar experience to what I'd have on my desktop. I'm going to zoom into a local scene layer package with 3D objects that have textures, right? So the textures themselves are really, think of them as bitmaps on 3D objects to give it that true look and feel. This is for the other app. Let's close that. So if I start to maneuver around here, I should be able to see as let's go ahead and go to tilt a little bit. So we start to see some of the data fill in. Now, one thing that might be a little bit of an issue here is our Ethernet's not too bad. What I've noticed here is that in order to get the performance that you want, you're looking at somewhere between 10 to 20 megabits per second, actually, if you want to be able to have a better experience or really a full experience. But this is pretty decent. If we look at the local, here we go. With our local data set, I can maneuver around here. Looks like it's probably just a networking issue here. But obviously I've got better performance, right? When compared to the remote desktop application, we can see that I have a responsive app, right? I'm using touch at this point, so I can interact with it, right? Maneuver around. And we can see we're using video memory. The GPU, as I maneuver around and actually need to load additional data, it's going to pop up to about 30, maybe 40%. It's going to be leveraged. Our local CPU is not getting hit in that case, right, as I maneuver. Right, there might be some additional work that needs to happen there to make sure that we're handling the different tile schemes and working with that. So some fundamental work there, but we're leveraging the GPU. It's available. We can take advantage of it. Right. So let's take a look at another application. We're going to browse out to the other graphics app, and this is using an incremental build. Actually, just a reminder: the incremental build. This is not available in the current Runtime SDK. But will be there at 100.1 or update 1. Unfortunately, this thing starts at full screen. Let's move this thing over because we don't need it. Oops. Come on, come on. I was a little hesitant to do that. Yeah, that's going to be a problem. Hold on. Let's restart that. This is incremental build, actually, so we're still working on this. So hold on here. Let's see if we can get that thing showing up here again. Yeah, okay, we're just going to move this thing over here. Can't seem to grab that. Oh, there it is. Okay, great. So now what we can see here is all right, we're getting over 60 frames per second. That's great. As I maneuver around the map, I can see I can get updates. It's fairly quick, right? There's a little bit of a lag. If I play this and I start maneuvering graphics, I can see video memory is being used. I can see my GPUs getting hit, probably about 14% or so. Let's see how the CPU's doing. CPU's about 16, 19%. Things are moving around. We're staying within bounds, which is great. Memory is reasonable. If I start tracking an object, we can see here we get a pretty responsive experience. Great. Okay, so our GPU's jumping up about 30%. Good stuff. CPU's up there too. Good stuff. We're going to stop tracking. Okay, great. So we'll notice here too that if I tick this little software rendering, obviously I'm using the hardware, right? So we can recognize that that in this case we're taking advantage of the hardware that's available within the runtime. Good stuff. So let's bounce back to the slides. We got one last slide here, just to close. Okay, so hopefully that was an interesting demo, showcasing some of the capabilities there with respect to really a GPU-backed virtual machine, in this case available in the cloud, but also capabilities that are available on-premise through different enterprise options. What we're doing right now with respect to status of ArcGIS Runtime is we're in the process of certifying different virtual environments, different virtualized platforms at this point. What we'd like to do is we're actually following ArcGIS Pro's lead. Pro has basically an extensive virtualization platform system in place for certification and testing. With the runtime, we're going to be leveraging that same experience. And so a lot of the recommendations that you find that are applicable to ArcGIS Pro are also applicable to runtime. So if you're looking for something immediate in the short term, you can use Pro as an example of what we're looking to target with respect to runtime. Now that does mean that there's going to be a process here. We have a number of runtime SDKs that this will apply to. And so it's going to take a little time to work through those certification efforts, targeted certification efforts, so that we can update our system requirements and provide recommendations. Right. So, but Pro is a great option here to take a look at. Actually, we have a virtualization island here next to the runtime island, which is showing off Pro and actually showing off a product that we have right now. Oops, that didn't work. Hold on. There we go. Showing off a product that we have, the ArcGIS Desktop Virtual Appliance, which is designed for Pro, but will work with runtime as well. Using an NVIDIA grid card on the back end, it's a sort of a pre-provisioned hardware appliance that you can leverage and start using today if you'd like. Obviously, these recommendations are going to include supporting or recommending using GPU-backed VMs. Right now, how you leverage or which technology you decide to choose, that's up to you. Obviously, we're going to support and recommend a variety and certify on a variety of the major players within the market, such as Citrix and VMware, Microsoft Hyper-V, and obviously Amazon and Azure. But we encourage using GPU-backed VMs for virtualization, right? And so most of these are built on top of the NVIDIA grid-based system. There's a variety of different clients. Obviously, we'd recommend using more of a proprietary client, such as Teradici's PC over IP, or maybe HDX, a Horizon View with VMware, working with a client receiver with Citrix, actually, Zen Desktop, Zen App, being able to leverage those for effective use of virtual deployments. Another thing to keep in mind here is licensing. You need to account for deployments so ArcGIS Runtime, the cost of ArcGIS Runtime is built around deployments, not around development. Development is free. But when you deploy your app, there's a cost. There can be a cost, right? If you're anything above the free license level, there's going to be a cost, and it's per app per device if you're using a license key. So if it's per app per device, you need to treat your virtual machine the same as you would a physical machine, right? Sometimes it's easier to keep track of because you know all the virtual machines. If you're an administrator, you know all the virtual machines that are available, and you can keep track of what's available on those machines too, right? So you know what's up, what's running, and you can track your runtime deployments. This is an honor system. There is no license manager, right? There is no phone home, right? When you get a runtime deployment, it's a paper license as to how many times you use that, right? So you buy it in deployment packs, and you allot those accordingly. So just need to consider the use of a deployment key or license key. If it's a paid license key, you need to track that on a virtual machine as you would a physical machine. Now, what makes this a little bit easier is if you decide to go with the named user model, the license travels with the user. Right? You don't have to track deployments. You just need to enable or you just need to enable the capability associated with runtime with a named user, right? So the named user, because the license travels with the named user, there's no deployment tracking. It's basically a more encouraged workflow for being able to license applications, regardless of whether it's physical or virtual. The only restriction there might be that named user isn't supported for all the license levels yet at this stage, right? But it is a lot easier to keep track of. Granted, named user can do a lot of other things. Licensing runtime is just one part of that, right? And there's a cost associated with a named user too. So just a couple things to keep in mind. When we start publishing our documentation on support for virtualized platforms, we're obviously going to include best patterns and practices with respect to licensing, just to give you an idea of what those issues are. So, and that's my last slide. Hopefully I wrapped up in time. Ooh, 1 minute over, sorry. If you guys, actually because I'm a minute over, if you guys have any questions, I'm going to wrap up here and I'll be right outside and then we can chat if that's okay. So, good stuff, great, thank you guys, thank you.